Hello and welcome. Today I want to try my hand at making a Pi KVM as cheaply as I can. I'm going to use some parts that I already have. I'm going to harvest some parts from some old electronics I have laying around. And I'm also just going to provide some parts that you can purchase if you are following along. I'm going to be following this Pi KVM's DIY guide loosely, changing stuff up where I choose and just designing and printing a custom case for it as well. All with the guiding principle of just spending the least amount of money that I can. For anyone who's unaware, a Pi KVM is just an ip-kvm that's built out of a Raspberry Pi as the brains of the operation. And an ip-kvm is just a way to remotely control a computer on a lower level. We're going to be able to get in and make changes to the BIOS. We're going to have control over the power button. And we're even going to be able to install operating systems all remotely controlled over a network. Normal ip-kvms can go for as much as $500. I have just one I searched for here. And even the pre-made Pi KVMs, they're about $250 or $160 just for the easy-to-use plug-and-play hat. And I'm hoping to stay around the $100 mark for everything. Depending on any parts you may or may not already have, that's going to change. For me, it'll probably be under $100, but that's just because I have parts laying around. That's what I want to try and do. Let's go ahead and get started. To start, we're going to need 5 main components for our Pi KVM to work. We're going to need a Raspberry Pi 4. You will need a 2 GB version or greater, so the 1 GB version is not recommended, though I've never tested it. A video input device to capture the screen of the remote computer. Pi KVM lists one from AliExpress that takes a while to ship. You can find it on their DIY page. This is one that I purchased on Amazon that I can confirm works. Supposedly you can also get USB HDMI inputs to work with the Pi KVM software, but they apparently have latency issues. I haven't used one and I won't be using one, so I'm not sure on those. Third, we're going to need a way to simulate pressing a button for the power switch, which we're going to do with an electromechanical relay. I think in the guide they use a solid state relay, but I have electromechanical relays laying around. We're going to need some custom cables to attach the Pi KVM to a computer while still getting power. The guide offers some splitters and stuff to buy, but we are going to save money by slicing up some existing cables and just making our own cable. We're also finally going to need the software to tie it all together, but Pi KVM has us covered with that. They have just essentially an OS that you flash onto the Raspberry Pi that does all of that stuff. We're going to start with flashing the OS onto the Raspberry Pi. Just because it's an easy step to perform, we can confirm everything's working. To install the operating system, we're going to go to the Pi KVM docs. This was just linked in, oh actually it's back one page. This was just linked in the DIY getting started. And we are doing the DIY Raspberry Pi 4 V2 platform, and then we're using an HDMI CSI bridge. So we're going to get the CSI bridge image file. We'll let that download. Image file downloaded. And extract it. Alright, and there's our image file. So now we just need to open up a program to flash this onto the SD card that I've plugged in. Alright, we got Rufus open. We selected our image file, which is the same one. See video files. And then go ahead and make sure you're on the right device and click start. Okay, we've got the SD card all written. Let's go and test it out. Let's make sure that worked and we can boot into the software, and also make sure we can just connect to the Pi KVM web server in general. So here's the SD card that we just flashed with the operating system. Just put that in there. I'm going to hook up network, and then over here I have a power cable. So, oh, I forgot. Mini HDMI on these, huh? One moment. Got a mini HDMI cable. There's HDMI 0 and HDMI 1. I'll go ahead and plug this into 0. There we go. We can see the power light. Well, that's interesting. I would expect. Okay, let me try a different power adapter. This was just a phone charger that I had. It might be this wasn't plugged in all the way. Ha! That other power adapter probably does work. But there we are. We've got this plugged in and booted. Our flash worked. The operating system is ready. Let's go look at it on a computer. So I found the IP of my Raspberry Pi 4. Everything's working so far, which makes sense. All we did was install an operating system. Let's move on. Okay, so we just performed a test of the Pi KVM software. We've got that loaded in, it boots up, we can access it over the network. Now let's see if we can get an image out of it. So we're just going to hook up this HDMI input board. I'll have a link for the one that I got, and there's also a link for one on the Pi KVM website where they link the one that they use. If you've never used these CSI or just ribbon cables before, there's a little tab right here. This black piece will flip up and then you can pull it out. So we're going to put it in with these pins facing that direction. Okay, so we've got that in. So now we don't really need video output. That was just to make sure that the Pi was even booting at all. So I'm going to plug in the network. I'm going to plug in a video source here. I'm going to plug in a computer. So let's plug it in. I am always scared of ripping these ribbon cables, at least when they're floating about like this with like a heavy HDMI cable pulling on it. That's plugged in. So now we're going to turn on the Pi and then go look at it on the network and see if we can get a signal. Here we are back on the Pi KVM interface. We now have the USB video device plugged in, and then that is in turn plugged into the video output of a computer I have. I'm going to go hit play while we're recording, or play. I'm going to go start up the computer while we're recording this and see if we get any video. Oh, did I unplug it? Ho-ho! There we are. Okay, so that video input device works, the one that I got from Amazon. So that's perfect. We now have the operating system installed. We are getting video input. Now we just need to be able to control the power button and the emulate a keyboard and mouse. But we can at least get a video input. So that's great. Here is the wiring diagram that we'll be following from Pi KVM. Really, it's just a power cable for a Raspberry Pi, but there's an extra USB cable hanging off of it. This USB cable will plug into the computer that we're trying to remote control and present itself as a keyboard and mouse. The reason why these all have to be combined into one cable is because the Raspberry Pi 4 can only emulate a mouse and keyboard across one port, one of its USB ports, and it is the one that powers the Raspberry Pi. Those four on the other side of it cannot emulate a mouse and keyboard for whatever reason, so that's why we got to make this special triple cable. here's our plan for doing this the cheap way without any of these special, easily solderable ports. They make these for type A male too. And that is, I'm going to use an old phone charger, 5 volts, 3 amps. That's what's recommended. You could probably get away with 2 amps, but probably shouldn't really go lower than 2 amps. So this has USB-C with data cables in it, 4 wires. That's going to go into here to power the Raspberry Pi. But if we look at the chart, the USB male type A plug, it hooks up 3 wires. It does not need the power, but it does need ground, data plus, and data minus. So I'm going to splice that in like this. If we want, out this way. So then we'll have one cable that goes into the wall, provides power, and then out comes a USB type A to plug into your computer. So let's go ahead and get that all wired up. Now normally I wouldn't tell you to just trust the colors that come out of cables. I always like to double check them. But with USB-C you're kind of going to have to. And usually USB's correct. I haven't really run into any USB cables that use weird wiring colors. I'm sure someone has. But without something like these breakout boards that I have, it's going to be really hard, because the idea would be that you touch the pins in there, touch a specific pin, touch another end with your multimeter. If it beeps or if the resistance is 0, then you're connected. But good luck touching any pins in there. So you would have to get one of these breakout boards, and then those are the 4 wires that we need. And we would just touch one end here and one end to the cable and confirm that. But again, we don't have these in our scenario. Okay, so power going out to the Raspberry Pi. Actually, why did I strip the white and the green on this side? We didn't need that. That's okay. Practice. Power from our power brick over here, right? Coming into here on positive and negative. And then this one, no positive. And we're just doing white, green, and black. And we're going to tie all 3 of these together at once. So black to black to black, green to green to green, white to white to white, but then just red to red. Well, I did some testing. This does still have the short, but I need a new male, a different male USB-C. Right, there are 3 wires on this table. This one that goes off screen is just our power. 5 volts, 2 amps. Here is our USB-C male. This one will go into the Raspberry Pi. Has all 4 wires. And then here is our USB-A male. And then just the 3 wires that we need. So I think we are finally ready. Alright, we may be doing this DIY and budget, but I think we can still make it look good. And this isn't a requirement. But I have a pack of heat shrink tubing here, just some assorted ones, got it off Amazon. So if we imagine what our cable will look like, the easiest way is to have them all kind of face up like this, and then they would join at this point, and then all 3 wires would come out. Looks a little nicer if maybe the power one comes in. So, power, and then the other one's here. I think I'm going to do it this way just to make it easy. So before we solder it all up, we need to put some heat shrink on. And again, this isn't required. We're still going to use the glue of the gods, the hot glue, the best DIYer's friend for just insulating wires and all sorts of stuff. To keep stuff together, but we're also going to use heat shrink to hide that, but we don't have to hide it. So let me just pick one. Here's a blue. Well, that's actually a great size. So as that shrinks, that should get them in there nicely. We'll just move that down, and we can get started. Maybe we'll use some other colors some more later, but all right. And since we cut all the wires specific ways, other than this change where mine is white and for the power, you should be able to just match color to color because we only have the correct number of wires available to us. So, for example, we can do black to black, twisting the wires and soldering them, and then having them both kind of parallel to a point is probably the easiest way to get this done. I think I already said that, but it doesn't look quite as good. White to white. And then let's do green to green. That is the USB-C cable tied to the USB-A cable now with the correct 4 wires. So the final one is power, ground to ground, and then positive to positive. Oh well, I'll figure that out later. Okay, now we have those wired up. There's green only go in one place, white only go in one place, and then ground was the only one that's tripled up, and then there's power. I'm gonna trim this off. So now this is going to be the trickiest part. If we just, bundle these up and then glue them or whatever, these can all touch. Especially these ones that burned off. They burned off quite a lot. So we are going to want to separate these a little bit and use good old hot glue to keep them separated from each other. Anywhere where there's metal sticking out, which we can test after it cools, you can feel it with your finger. We really just want to make sure everything is super separated. I'm also going to glue the wires themselves. Well, I mean, they're all wires, but glue the shielding of all of the main wires together to make it more like one cable. It's going to look nice and ugly. I don't know if heat shrink can even save this. I have them all spread out really far because I'm more scared of them touching than I am of it looking nice. But, I mean, however you want to do it. If you want the wire to look better, there's a bunch of different ways to solder these. So, we've got our grody cable. Let's see what we can fix with heat shrink. Oh, wow, this is going to be... That's as far as that's going up. Yep. Well... That'll still give us some good strain relief for all the cables coming out of there. Yeah, that doesn't look bad. Oh, fuck. Cover this up however you want. I am just gonna say fuck it and not. Hey, I was just reviewing the footage and noticed just how ugly that cable was. I still think, bundling the wires kind of all in one place. Imagine this was cut. There's 3 wires there. kind of being able to twist it and solder it and glue it is easier that way. I did make a fucking monster of a cable, but I also wanted to show that you can make nicer cables too. This is one using some extra parts, so it was cannibalizing cables, but I used a breakout for a female and male USB-C. You can see the power comes in here. This would go, come on, this would go to your charger, and then this would go to the Raspberry Pi, and then those 3 wires are coming out to this. And then I'll also put one up on screen. This one I made with a friend for his Pi KVM, and it is completely cannibalized cables. There's no extra parts other, I guess, heat shrink. If you count heat shrink, that's part of what makes it look nice. But it was just a little bit better of a soldering job, but it was also harder. Doing what I did in the video is a little easier if you haven't done soldering before, but just wanted to show you that it doesn't have to be quite so ugly. There's the cable that we made. We have power, a port for the Raspberry Pi, and then we have a port for the computer. I'm just going to plug this into a Raspberry Pi and hope that it turns on and looks fine. And I can see it connected over there, so the power has worked. Kitty, what? The power has worked. Say that to my face. Let's plug this into a computer and see if we can get it work. This is where it starts to get cool, because we can actually start to remote control stuff. We've got our beautiful cable here, and this will power the Raspberry Pi, and this will go into the computer, and we're going to be testing with this little test bench I have set up, USB plugged in. And then let's plug power into the Pi. Okay, the Pi is booting. Oh, we also are plugged into the network. HDMI board's light on, HDMI is in. Okay, let's go look on the computer. Okay, here we are. We have everything hooked up. Our new USB cable is hooked up. Go to KVM. Ubuntu has booted. Oh, and look at that. Oh my god, this never gets old. You can see up in the right, there's mouse and keyboard stuff. We're controlling the mouse. Oh, I love that. So, this is a pretty functional KVM. You could stop here if you decide you don't want to deal with pressing the power button. Pressing the power button is going to involve touching the pins of a motherboard and setting up a relay and a few things, but we're going to get that done here next. But so far, this is cool. This computer's not even hooked to the internet. Like if I go, is there a visual way to show you? If I go to network, cable unplugged. We're remote controlling through our Pi KVM computer that is not even connected to the internet. And because we have our USB stuff all set up, that also, oops, didn't mean to close that. I don't actually know how to get it back open. But we can also emulate flash drives, USB data. So it allows you to upload some images, but we'll get into that a little later. Well, it works. Our ugly cable works. So the next part of this is controlling the power button of our remote controlled computer through the Pi KVM. If we look at Pi KVM's breadboard diagram here, we can see it does a number of things using 4 solid state relays. And I'm going to change some of this. First, I'm going to skip over most of them. I personally don't think we really need to see the power light indicators or access to the reset button. That's just less stuff to do and inherently cheaper, and we're not really losing much functionality. The most important thing is pressing the power button. And second, I'm going to change these to electromechanical relays, not solid state. Mostly because I have electromechanical relays laying around, but also because they're much more available on places like Amazon in cheap, like packs of 10. You can get the right kind of solid state relays on places like Mouser or DigiKey, but it's another website to order from. This might be the only part you order from them, so shipping might not be favorable. And really it works out to either be the same price or a little more and I think electromechanical relays are just more widely available in the Raspberry Pi and Arduino community. The relays are used for a lot of things, and they're in a lot of tutorials, so more people are likely to just have them laying around. If we look at Pi KVM's documentation, we can see that the software they wrote just flips on GPIO pin 23 when you tell it to push the power button of the remote computer you're controlling. You can see this with the green wire going from the Pi to the breadboard. That's pin 23 on the Pi going to one of the relays at the top. So here's a beautiful diagram I drew of a relay. In this example, the small battery down here is the Pi putting out 3.3 volts on pin 23, and this whole upper area is the front panel connections to the motherboard, specifically the power switch. If you've ever had to plug those in on a custom case, that's what we're going to be plugging into. So when you put power through this bottom one, or when the Pi turns on pin 23, it turns on a magnet that closes the circuit above this whole section while keeping them separate. It physically moves a metal piece to complete the circuit. It's essentially flipping a switch with magnets and electricity rather than your finger, and this lets us press a button with electricity. So remotely pressing a button, which is exactly what we need to do to turn on the computer. So we just wire up this bare relay to GPIO pin 23 and ground, and we're done, right? Well, not exactly. Technically it will work, but for one, the most common relay types run on 5 volts, not 3.3 that the GPIO pins do, but you can usually trigger them with 3.3 still. But most importantly, the Raspberry Pi 4 can only handle so much power draw from a GPIO pin, roughly about 15 milliamps. Whereas the 5 volt power rail, which is always on, it's not a GPIO pin, can handle 1 full amp, or roughly 66 times more power running through it. And that's where relay modules come in. Relay modules are powered by the 5 volt rail through these two pins, so they always have power going them, but then they're triggered by the 3.3 volt GPIO pin. This makes it so most of the power draw is done via the 5 volt rail, and we just trigger it with the GPIO pin. The easiest thing to do here would be to buy a relay module like this one, but in the spirit of being very cheap, I'm going to make one with harvested parts. Here is a DIY relay module made by DIY Mechanics on Instructable Circuits that we're going to use. If we go through it, we can find that it's really just an NPN transistor, a diode, some resistors, and of course the relay. There's an LED to show when it's on, like when it's being triggered, but I don't really think we need that. So let's go ahead and scour some old broken electronics and build our own relay module. Here's some stuff I had in my junk. I have a box full of just cables and stuff and boards that I can abuse. So this was an old clock. And on it, I did some looking. There is a transistor right here, so we'll have to see if that one's okay to use. And there is a diode right here, and in this case, pretty much any diode's going to be fine. But this one is actually, if we look at the numbers on it, an N4001, which is the exact one that it tells us to use in there. So that's great, which they're pretty common. So we definitely have a diode here. And then we have a transistor there, and I don't know if that one's NPN or not. And then this is an amplifier board that I fried that we can use for some parts. And on here we have some resistors. I checked those with the DigiKey calculator because it's way easier than memorizing this stuff. And these small ones are 100 ohms. So I think that should be plenty. We might double them up to make 200 ohms. We'll see what our power draw is like. And then we also have another transistor right here. And this one I did look up, and it is an NPN. It's a big one, but it should still operate at the voltages that we're trying to do. So transistor, resistors, and diodes, that's everything we need to make our relay module. So let's go ahead and desolder those. Come on. There we go. There's one diode. There we go. One resistor. and 2 resistors. So I'm going to run this across all 3 of these pins quickly. Woo! That was quick. And there it is. Got a little warm, but that's our transistor. I think I have some pictures of it, but this is, you can't really see what it is. It's like a C2383. Oh yeah, there you go. So I looked up the data sheet of that. We can pull that up. Here's the diode. This is a pretty basic one. And then there's our 2 resistors. So with these and our relay, so far we have paid nothing for any of this. Granted, you probably will have to buy a relay because they're hard to find and stuff, especially 5-volt ones. Alright, let's put together a test circuit with this relay. We're not going to use the harvested parts for this demonstration, but we will use them when we do it for real. But I do have some spares. If we look at the Instructables guide, we have some pictures on how to set this up as a breadboard, and then I'm just using some unused components since they'll have some longer legs and things like that. So we're not going to use the LED, but we can just put these in here and then kind of test the circuit, go over, why things are the way they are. So we've got 5 volts going into the relay. If I show you the underside, these are the 2 pins that we need to connect to make it click. So I've got this in the breadboard. That center pin you saw is just not touching anything. We've got 5 volts coming in, and then we've got negative going to the collector of the transistor. And then we've got this resistor is how we're going to trigger it. That's just in line with GPIO pin. It's going to connect to that just to kind of make sure we're not drawing too much power or anything like that. And then this one we're going to take to ground. So I'm just going to use, I've got some of these. So that is the emitter, and we're going to take that to ground. Now we just need to plug in the diode, and the diode has to go a specific direction. That line has to touch the positive because diodes only let electricity go through one direction. So the electricity can go through this direction. So if we put it in here, on the guide you see it's going in between the positive and negative. We have to make sure it goes the right way. Otherwise, if we flip it this way, so positive can just go straight to ground, it's just going to be on all the time, and it's going to get very hot. So with this, we have 5 volts coming in, and then we're running, our ground is going through the transistor to ground, and then we just have to send a small amount of electricity on this pin to turn it on. So the important things to remember here and keep track of is that 5 volts is on this breadboard, right? So 5 volts is running through this, but I'm going to be using my power supply set to my other power supply set to 3.3 volts. So we're injecting 3.3 volts. Just like on a Raspberry Pi, 5 volts comes out of this corner pin here. But 3.3 volts is what comes out of the rest of the GPIO pins when they're powered on. So 5 volts is going to be running through this relay, but we're going to be triggering it with 3.3 volts. So this is just to my other power supply so that they're sharing a ground so that this will work. Just like the Raspberry Pi, the 3.3 and 5 volts are sharing a ground. So if I do this, it should work. And it does, it turns on. So the important part here is the amperage on our 3.3 volt power supply. So let me take you over to look at that. So there's our 3.3 volt power supply, and let's see how many amps it pulls when I hook this up. Hopefully you heard that. See, that's 21 milliamps, 16 milliamps. That's good, but it's not below the 15 that they recommend. So I think we're going to change a resistor. This one is a 100 ohm. Let's try this 400 ohm. Well, would you look at that? I don't think it's actually 0, but it is not registering when I do that. So I bet if I do two 100 ohms, it'll work just fine. Okay, these are our two 100 ohm resistors soldered together, so across this whole thing should be 200 ohms. So let's just use that one, since all we got to do is put it in here and then connect this. There we go. That'll work. Let me show you. So we're using 6 milliamps. Perfect. Okay, let's start putting together this circuit. I don't think we need a circuit board. I think we can kind of just cram it all in here and make it nice and compact. So here's our diode that we harvested. Remember that this band is the positive side, and so that's where we're going to want to put positive 5 volts from the Raspberry Pi. And we're going to go across these legs that have the third one. This is where the coil is, and then this third leg is either connected to this one or this one, depending on where the reed is. There we go. We've got a diode connected to positive and negative. It's the same thing as this diode right here. Next, we need to figure out which one of these legs. We've got 1, 2, 3. We've got emitter, collector, base. Really? Emitter, collector, base. So it's not even the middle one that looks. We might have to do some testing with this one. And if this is correct, then this, then this right pin is which one will trigger it. Haha! Okay, our data sheet was correct. So we need to get this middle one. That's kind of annoying. This middle one over to here. I'm just gonna put some hot glue right here. And attach. And then we can take just some spare leads we have laying around. Oh, I just threw some of them away actually. See how well it fits. So we need to connect that middle one. Hey, that looks pretty good. Great. Does this help? Yeah. Here I'm just soldering that 200 ohm resistor that's made up of 2 resistors that we pulled off the boards. I'm adding it to the leftmost pin on there. Okay, so we are now on to the final thing that you will probably want to buy. There's a few things I mentioned, but you don't have to buy all of them. But that are these ribbon cables. There's some ones with male connectors, male to male, female to female, male to female. And just getting a pack of these, it's like $6 and you get, I think, all of these. And that will be nice because then we get these little connectors that we can slide onto the pins of a Raspberry Pi, like so. You don't have to use it. You could solder to those pins on the back side if you don't want any of these. But the other thing is that these are also the right size for the pins on your motherboard, the power button pins. So these will come in useful twice. So I'm going to use these. You could easily get away with just soldering this into the Raspberry Pi, and then just to go out to your computer, you could harvest some of these power cables. So see, this is a power LED cable. I took them from some old cases. Some of them are pretty old, like this one's a speaker one. They don't really do that anymore. And then here's a turbo switch. That's really old too. But you could take these from old cases, just get this and then solder this end in. But I have these nice cables, so we're going to need one for power for 5 volts, one for ground, which will go on this pin here, and then one to trigger, and then 2 that'll go out. That'll just be like the one that goes out to the motherboard, but we're just going to do a female connector on the end of it so it only sticks out a little bit. And then you can plug in longer cables that'll go into the case. Here's 2 of them, and then we're going to need one. If I pull one of these off, we can get 2 of them, so we'll need at least, let's do 1, and then a half. So I'm going to start with this one. So there's our positive and negative. So let's remember which one's negative and then at least remind us. So where the diode connects to the top with the band, that's where 5 volts is coming in. So yellow is 5 volts and orange is ground. So to help us remember, we're just going to Sharpie up orange. There we go. Okay, so let's just bend this gently in a way that makes sense. So if this is going to be power, they're going to go somewhere over here in this top left corner. And this one's going to go kind of somewhere in the middle. So it'd be nice if this bent around and faced kind of the same way. Well, actually, let's test this. Technically, we're done. And if it works, we will throw some glue there so that it doesn't tug on any of those. So we should hear this click. Beautiful. Here I'm just soldering on the last 2 wires. These are the outputs. So those 3 wires you see from the top, that's power, negative, and then the trigger. And then these 2 green wires coming out of the bottom, those are the 2 connections that will close when the relay goes off. Alright, it's still cooling, but that is our relay module, made tiny. So if we are to hook this up, we're going to take this to one of the 5 volt inputs, positive. Remember, we drew on this one. That one is going to negative. And then this trigger, you kind of just have to count. I don't remember what GPIO pin number that is, but 1, 2, 3, 4, 5, 6, 7, 8. 8 down. So if we go 1, 2, 3, 4, 5, 6, 7, 8, it's this pin. Okay, those are the inputs we need. And now we should be able to boot this puppy up, open up the ip-kvm, and see if we can make this relay click with the power. Okay, we're all wired up. We should hear this click. We are powered, and we're on the network. We don't have the video hooked up because we already know that works. So if we come over here, oh, that's hard to see with the lighting. If I click ATX, I'm gonna click power. Are you sure you want to do that? Let's hopefully we get a. No! Oh, I don't know if you heard that. I'm gonna get you right near it, and I'm gonna press it again just so that you can. Okay, here we go. 3, 2, 1. It worked. We successfully used an old relay that was laying around, and we built a module out of trash, out of an old old circuit boards, from a clock, and from an amplifier, and we made a tiny little relay board. We removed some pieces of it, but that's okay. We didn't need a light that tells you when it flicks on, because It's going to be inside anyway. And I mean, I guess, is that really it? We just removed the light. Awesome. That's a tiny little footprint relay board. I like that. So then this will be sitting there ready for some other much longer wires to plug in. Am I in frame? Yeah. To plug in like so. And then, actually I guess technically it would be these ones. These wires would plug in like so, and then this one would go to the motherboard. So we are ready to test completely. Let's hook this all up and then do a test. Okay, we're ready for testing. We've got our garbage cable made out of cannibalizing 3 USB cables. Well, I guess 2 USB cables and a power brick. Its power comes into here, but there's also data cables running into the USB. And then power just heads off that way. We have our HDMI plugged in from this graphics card. We have our little relay module that we made. And its 2 wires are going to the power switch header on this motherboard. Everything's on. Let's test. Let me log in. Go to the KVM. Okay, we're remotely controlling this computer. It's not on, and we need it to be on, and we want to, and we're not at home, but we forgot to turn the computer on. If we go over to ATX, let's click the power once. Listen for the click. I heard the click. I don't know about you. It started it. Now we should see a video signal here soon. Look, let's get into the BIOS. That's not normal, right, for remote control. Pressing delete. And we're in the BIOS. Oh, this is so cool. And we made this ourselves for less than $100. Probably. And then let's try the long press. Okay, so let's try. Oh no, our operating system is frozen. Let's click power and hold it. We have to kill it. It's crashed. That's the word I was looking for. Okay, I'm gonna click this, but I'm gonna put you near here so we can listen for the clicks and you can watch the fans. Okay, 3, 2, 1. Click, it's holding. And it turned it off. Oh, that's so freaking cool. Next, I had a whole section on designing a case for this, but this is already a huge video. So here's a quick montage. I took an existing case from Thingiverse made by Lazix, and I imported it into Fusion 360 and then essentially made it bigger, added some holes to mount all the stuff we're jamming in there, and in the end, this is what it looked like. I've uploaded this case as a remix of the original to Thingiverse, so you can find a link to it in the description. Here I am just putting the case together. So first I mount the HDMI board with some M3 bolts and screws. You can see me putting those in here. Checking the fit. And next you can see me sliding in the green wires, those are the output ones from our relay module, through the hole out the front, and then gluing it in place with, you guessed it, some more hot glue. And with all of those, with those 2 things in place, you really just need to sandwich this all together, and then making sure those 3 wires from the relay and then the ribbon cable are all hooked up, and then the case just snaps together. So once those are all in, I mean, we should be done. I don't seem to have any footage of me actually closing it, but it's just making sure those wires are connected while you close it. I mean, we tested the thing without a case. The other thing you'll notice is that I added a fan. This is just a 3.3 volt 30 millimeter fan. I just had it laying around. It's not required, but the pi4 does run hot. You really just plug it into the 3.3 volt and ground pins on the Raspberry Pi. So that's it. You can see the USB coming out into the computer. We're plugged into the power switch, and we have HDMI input. This thing's all put together and finally finished. Let's give it a final test. All right, let's put this thing through its paces and do something that you can't do with regular remote access, and let's completely reinstall the operating system on this computer that we have over there. In the drive, I have already uploaded an Ubuntu ISO. So let's mount that, boot into the BIOS, make sure that we have it set to boot from this pi KVM device, and then reinstall over this existing operating system. Mash delete. Alright. There's Eufy pi KVM CD-ROM right there. There's this one and then one called Partition 1. I don't know the difference, but I'm gonna drag this one up to the top. So pi KVM is first. There we go. So we're booting into the Ubuntu, the 2204 live server edition. So while I let this final shot of me installing Ubuntu over the pi KVM, I just wanted to wrap things up. For $100, probably, or somewhere around there, we built a pi KVM by salvaging some old USB cables, building our own relay module, or buying one, and 3D printing a case. We paid $30 for the HDMI Capture device, $40 for the Pi, $5 to $10 for the relay module, and $15 for some DuPont wires and some nuts and bolts to finish it all off in an easier way. Sure, I think you could argue about all the existing tools that I used or the parts that I had laying around, but I also think it's fair to assume that there are plenty of people out there who are into electronics that have things laying around just like I did. And if you don't, maybe that's something that you want to do. If you like electronics tinkering, you will get to the point where you have stuff laying around. We got to have some fun completing an electronics project that also leaves us with a very useful ip-kvm, and hopefully we learned something along the way. Thanks for watching.